Good morning, students. Next our experiment is KCL, Kirchhoff current law experiment. Okay, so these are the theoretical calculations. So according to statement, you remember, algebraic sum of all the currents in a closed loop is equal to 0. We can prove that current value I1 plus I2 plus I3 equal to 0, or otherwise I1 equal to I2 plus I3 value. Okay. So in our kit we have this type of circuit, but in your kit circuit is completely different, in the sense you have to calculate theoretical calculation according to your circuit. So whatever it may be the circuit and whatever it may be the resistance values, so we can follow up the these calculations only. So then this is the complete calculation part of the KCL, Kirchhoff current law. Okay, you remember here, according to nodal analysis, I am taking here V1 is a first node and V2 is a second node. So V1 I am going to take it. So this part is completely I1 current, and V2 we are taking a ground terminal, so that ground terminal is always V2 equal to 0. Okay, according to nodal analysis calculation. Okay, then V1 minus V2, so this one is I3, and V1 minus V2, this one is I2. So we are measuring I1 current and I3 current and I2 currents. Okay, so according to that we can calculate here I1 is equal to source voltage minus V1 minus V2 by whatever the resistance is there in between V1 minus V2 minus Vs, that resistance is 100 ohms. We can replace here 100 ohms, that is equal to 15 volts minus V1 by 100 ohms, because V2 is ground terminal, that ground terminal is always 0 potential, V2 is 0 here, and here also same, I2 equal to V1 minus V2, and whatever the resistance is there from this V1 to this V2, that resistance is 220 ohms, that 220 ohms we can replace it here, V1 minus V2 by 220 ohms. So V2 is always potential, ground potential is 0 now, that's why we can replace V2 is 0. So V1 by 220 ohms, and here I2 we can take it, I2 is from V1 to V2. So here only the I2 value. So that resistance is in between V1 and V2, we can take it 120 ohms, that 120 ohms we are taking here. V1 minus V2 by 120, that is equal to V1 by 120, because V2 is 0. Okay, this is the calculation part. From that we are calculating I1 equal to I2 plus I3. It's mean according to the statement, in all incoming currents are equal to outgoing currents. So according to this node point, we are taking I1 is a incoming current for this node, and I2 and I3, these two are outgoing currents. That's why I am taking incoming current I1 equal to sum of outgoing currents. So it's mean this incoming current is equal to this I2 and I3 current. So according to that, already we know that I1 and I2, I3 values, those values I have replaced here. Then according to that we are calculating, in the sense we are getting V1 is equal to 6.55 volts. It's mean V1 voltage is 6.55 volts. So that 6.55 volts we can replace in I1 and I2 and I3 values. So I1 equal to 15 minus V1, V2 is 0 already, V1 is 6.55 by 100. So from that we can get a 0.08 amperes. So I2 equal to V1 by 120, that V1 by 120 in the sense V1 already we got 6.55 by 120, that is equal to 0.054. Then I3 equal to V1 by 220, that is equal to 6.55 by 220, that is equal to 0.029. So according to this we got I1, I2 and I3 values. We can replace here I1 and I2 and I3 values. We can get it 0.08 equal to 0.054 plus 0.029. So this 0.08 is equal to these two summation value. Okay, this is the theoretical calculation part completely. Okay, then we will go for practical circuit diagram. Already we done KVL. So same circuit diagram, same control panel. Here you remember, from this only we can get it KCL also. So you remember here this is a power supply, black point is connected to black point and red point is connected to red point. So it's mean this is a DC power supply actually. So we are getting in our laboratory AC power supply. That AC is converted here into DC. That DC only we are connected to here to the DC power supply. Okay, and then we have a 3 ammeters here. According to circuit, we need to take 3 current values, I1 current and I2 current and I3 current. We need to measure it. So for I1 current 1 ammeter and I2 current for 1 ammeter and I3 current for 1 ammeter we are taking. So that ammeter symbol here given. So that ammeter 1 I have connected for 1 ammeter. That one is a 200 milli ammeter DC. So according to our calculation we need a less current values. Because of that I have taken 200 milli ammeter DC. Whatever the value we are getting here, so that value into 10 to the power of minus 3 we need to take it, because this is a milliammeter na, so that's why. So here first ammeter I have connected for this one, and this is the second ammeter I have connected for second ammeter, and this is a third ammeter I have connected for third ammeter. So first terminal for ammeter first terminal and second terminal for second terminal. Okay, then we have a 3 resistances according to circuit, 100 ohms and 120 ohms and 220 ohms. So here you remember this one is a 1 resistance R1 and this is a R2 resistance and this one is a R3 resistance. So according to our circuit, R1 resistance is 100 ohms. That 100 ohms I am going to take from these resistances. 100 is there here. First one is 100 ohms I have connected, and the second resistance you remember here, that one is 120 ohms. So I am going to connect here 120 ohms. And third resistance here 220 ohms according to circuit. I am going to connect third resistance here, 220 ohms first terminal and second terminal. Okay, completed. Then we need to connect, no need of R4 resistance and this ammeter. That's why I am going to skip this entire thing by using one patch card. I am going to skip it completely. So it's mean bypass entire value from here to here. Okay, here already line is there. It's mean line is there in the sense automatically there is a connection in between. Then I am going to turn on the power supply. You remember, according to our theoretical calculation, we have taken 15 volts power supply. So here I am going to take 15 volts power supply. By using multimeter I am going to test it here, 15 volts. See here, you remember, so across this power supply I have taken one voltmeter, DC voltmeter. So in that DC meter, you remember 15 volts I have taken DC. So I kept in multimeter at DC 20 volts. Okay, so 15 volts I have taken according to theoretical calculation. Then you remember here, in first ammeter we got 84.3 into 10 to the power of minus 3. Already I said that one. So because this one is a milliammeter, no, that's why we are taking whatever the value we are getting here into 10 to the power of minus 3. So 10 to the power of minus 3 we are taking, in the sense we can get it 0.084. So that value only we got it first ammeter, I1 current 0.08. Okay, 8. Here we got 0.084. Okay, and second ammeter, you remember here 57.5 into 10 to the power of minus 3, it means 0.057 amperes. Okay, so here also we got second current value 0.054 amperes. And third ammeter, you have to remember here, third ammeter, third current value, I mean I3 current value to 29.8 into 10 to the power of minus 3. Okay, this is also a milliammeter. So it means 0.0298 amperes. So I3 current also we got same 0.029 amperes. Okay, so according to our theoretical calculation and practical values also completely verified and proved. So this one is a Kirchhoff current law. So practically verified.